and how FI works. Then probably we will be going to discuss about how FI is a different DNS solution. But currently, if I talk about FI networks, it is a company or organization, and FI networks provide lot of product suite. One of the product suite family is big IP, out of which there can be n number of the products. Let me tell a couple of them like LTM, GTM, ASM, APM, AFM, ARM, and a lot more. Okay. So here, if we're going to talk about, we will be touching this part. But for FI GTM, which was a former name, new name is FI DNS. So for FI GTM, I am expecting that you guys are aware about the working of the FI through the FI LTM. Okay. If you have a little bit knowledge for the LTM, like how pool works, how virtual server works, what is the node, what is the load balancing mechanism, how the health monitoring part be taken into the consideration, that would be good for our GTM class as well. Okay. So let's jump to the FI DNS, like how FI DNS make a difference. Before that, if we talk about what is a DNS, simply, what is a DNS if I say, so can anybody let me know what is the DNS?
This is the resolution.
Correct. So DNS, which is domain name system. Okay, the abbreviation of the DNS is domain name system, and this is something which resolves the IPs to the name and vice versa. Okay, so we can say it is a distributed database or the phone book of internet, bit like your directory. Okay, phone directory of the internet. So primary job in general, as an overview, if we talk about, if I need to resolve something like www.cisco.com, okay, eventually it will be get resolved into some of the IP address. Okay. Now, if you will ask that, okay, what is the requirement? Why we need to, convert it into IP address? So for the same, probably we need to go to the basic fundamentals of our IP world. So if a client need to interact with any of the application or any of the server, when packet will get formed, it will adopted the OSI layer or the TCP IP layer, whatever you wanted to understand, probably you can think like way. So eventually, when your traffic will come to the wire, it will adopt the binary thing only, 1011. Okay. And your packet will form that, okay, what is your source IP, what is your destination IP, and what is your source port, what is your destination port, and but obvious MAC address and the lower layer and the upper layer, all layers will come into the picture. So when your packet is getting formed, it will not see the name. What it wants the destination IP. So let us say if this PC need to interact with this particular website, and for the namesake, I am just giving some hypothetical name like abc.com. So if this has to go to the abc.com, before forming this packet, okay, before forming this packet, which will traverse over the wire, it will check through the naming resolution process, like what is the IP of abc.com. I'm just taking again an hypothetical IP 1.1.1, and it will just fill up into the packet that, okay, the destination IP is 1111. Let us say you are interacting on 443. So your source port would be any random port, let us say TAT, your destination port would be 443. whatever the IP of your source, like 1.1.2 or maybe anything. So it can be have that IP in the source packet. That is how your traffic flows. But it is not so much easy because I just created a PC and a server directly connected with each other. No, it doesn't happen in real world. Actually, there can be so much devices in between. So if device need to interact with some of the server which is placing over the internet, before that there can be some kind of load balancer. Before that, there's something can be of the firewall. Okay, and before that maybe some router or something, the inet router, and that is how the data center of this particular application builds up. So let us say it's a NetMinion server and we are interacting with netminion.net. So in that case also, if we see clearly, this packet will cross all of these boundaries one by one. And that is how your traffic will flow from your PC to last server. Here on your PC as well, there can be like after your PC, there can be some kind of modem, okay, the provided by ISP, then ISP router or the firewall structure, and then there are some clouds. Okay, so if we talk about the naming regulation, there is a process. Every naming regulation has some process, and we need to aware about that process for simply understanding the DNS flow. So DNS is very easy if you understand this process. Okay. So for the same, there would be couple of the terms which will be coming in front of us, and we need to understand one by one. So let us say this client wants to resolve abc.com. Okay. The very first, this client will ask from its own browser. So is it present in my browser cache? Is it present in my OS cache? Further, it will try to find out that, okay, if not browser, not OS, then it will be gonna check about the same cache field in with the help of something which ISP provides you named as modem. Okay, it will just check that either in my modem or my local DNS is this entry present there. If not, probably some another regulation will happen. If yes, then the regulation area would be different. So if one of them, browser, OS, or LDNS, has this entry present, it will give that IP address directly to the PC. Okay. And with the use of this IP address, the packet can get formed. Let us say if this is not a case, then the naming regulation process would be little bit different. What would be that? There is a PC. This PC need to interact with some of the website. Okay, so what I was saying that this PC need to interact with the server. So to do this, it will just enter the website name abc.com. Okay. When client enter this, it will check the local caches. After that, it will see that this is does not present in my cache. The client will forward it to the LDNS. Local DNS will check that okay, either it is present in my particular specific database or no. If yes, the query will resolve. If no, this query will further continues. And till where it will continue? Till we didn't receive any of the IP address. So LDNS will forward this query to something named as root server. Now it is very interesting. What is root server? So if we are just putting www.abc.com and after that there is a hidden dot presents. This dot is nothing but it is a root server. So this query will go to the root server. Root server generally named as dot server. Okay. This root server will check either abc.com. I am recognizing this or not. So this root server never resolve the query. It will further delegate the query to something named as top level domain. Here in our case, we are searching for abc.com. So the hierarchy will be going to the .com. Top level domain will see that, okay, I am having something www.abc.com. Do I have some information about it or not? And it will send this query again to something named as authoritative DNS server, which is placed by ABC organization, and it will be checking abc.com. So again, your query is going to the root server, from root server top level domain to authoritative root server. Authoritative root server is the one which will resolve this query and will give the actual IP address, let us say 1.1.1.1. When this IP address will go to the LDNS will store this query into its cache. First thing is it will store this query. Secondly, it will send this query to the PC. So when we talk about that, okay, our website, our any of the client is interacting with the website. Okay, as I told you earlier. So there is a whole cloud. Probably all the fields are hidden in this cloud. So when PC need to interact with some website, it means that there would be two processes which will follow. The first process is the DNS resolution process. So if DNS resolution does not take place, your packet cannot form and your website cannot work. And that is what you can observe in lot of scenarios when application owners are saying that our website is not working. It doesn't mean that their application server stopped. It doesn't mean that their actual application is not working. It can be that DNS resolution is not happening, and that is the reason packet is not getting formed completely. And since packet is not formed, your client will say that, okay, I am not able to interact with the end website. And that is how your DNS resolution is the very first important step whenever you are accessing any of the website. So this is DNS resolution process, where first thing you will resolve the IP. Second thing, the packet will get formed. Third, that packet will be get transferred from wire to wire. And similarly, from the other end, response will come and you can open this website on your PC. So when we open any of the website, see how much series of steps we need to perform. Okay. But as an user, it happens in the background, and even we didn't realize that such a huge, series of transactions happen. So if I need to provide the steps to you guys, okay, these steps can be just illustrated as below. First step, client will enter the name. So whatever application he or she wanted to access, that will be get entered like netminion.net. Second, when client is entering this name, the DNS resolution process starts. Again, if there is nothing in the cache, this DNS request will go to the local DNS server, and which is LDNS. Majorly, whatever modems we have, those are working as the DNS server also. So these are the two steps. Third step, when LDNS will check this, and again, if caching is not there, LDNS will forward this query, to root server. Fourth, when this packet will go to the root server, just for your information, never give you exact IP address, but root server respond with some another server. Okay, so it will just resolve and it will see that, okay, this is .NET in the last, so just go to the .NET server. Once your query will go to the .NET server, what happened then? Your now your LDNS is aware where he need to send the query to the .NET server. So in the fifth point, your LDNS will send this query to .NET server. And also there can be one .NET server, there can be more than one .NET server, there can be multiple .NET servers available. Once this query will go to the .NET server will check that, okay, do I have NetMinion domain registered with me or no? If yes, this .NET server will provide again some DNS server named as authoritative name server, and it will give this query that, okay, go to the NetMinion.NET server. So LDNS is still receiving a response that, okay, you go to the NetMinion DNS server. Now LDNS will forward this query to NetMinion.NET server. Okay, you can see the series of steps, and these are the resolution steps. Maybe you can say DNS resolution steps. When it is going to the NetMinion.NET server, it will check that, okay, this is my domain, and do I have entry for this or no? So it might have some A record or some form of records present there, and it will give an IP address. So the authoritative name server will always give you the IP address if there is some entry. How to create these entries? What is A record? What is C name? What is text record? What is SRV? These all records we will be gonna check. What is the domain? We will create our own domain. Later on, I will show you in the lab that how we will create our DNS server. So we will gonna create the DNS server in actual on the Linux machine, and those Linux servers which will act as a DNS server will resolve the whole this naming process. And there I will show you all of these steps again. Okay, but for now we need to understand in the theory. So once IP address is achieved, LDNS have that IP address. Okay, LDNS have that IP address. LDNS will give this IP address to the client and also save in its own cache. Once this part is done, 10th client will interact with the actual application, and that is whole form of networking. We already aware with the OSI layer and maybe TCP IP layer that how these all steps done. Okay, so these are the major steps which will keep on coming when we need to do the DNS resolution. I hope it is clear to you. If there is any doubt, maybe you can just type it. Fine, thank you. Okay. Let me just resolve this and show you something like how our lab will work. So if you see this is a simple topology which you can see on your screen. This topology is depicting like how practically we need to perform all of these tasks, not theoretically, but practically all of you will get your own lab setup. Okay, and this is the different code for different people. It's not like that if person A is doing something, person B is also receiving the same configuration. No, there are different ports for different students. So if you see here, we can check that there are two data centers. One data center is depicting the EMEA, one data center is depicting the APAC. So why we require two data centers? For the same, again, I need to go to the whiteboard and need to talk you about the application architecture. So when you have one application in a data center, let us say this data center is present in Delhi. Okay, or maybe we can say for the APAC region. So this data center, you have just hosted a new application server, and clients across the globe are coming to your data center, accessing the application, and everything is fine. But your business is expanding soon. Okay. When your business will get expand, one part is you place here the multiple servers, and before that there is some LTM device you can place. Okay, so that your, or maybe I can say load balancer you can place, so that your traffic, local traffic can be load balanced. Second thing, what if a person is coming from USA? What about the delay? What about the latency? Those factors also need to be taken into the consideration. We cannot skip those parts, right? So for the same, probably the same application, we need to onboard on different regions for different customer database. So let us say this time we build up 3 data centers. One data center in the US, one data center in the Europe, or I will say EMEA, and one data center in the Asia Pacific APAC. Now the same application abc.com is working on all of these 3. Now the typical solution for the user can be, you just taken one private IP, sorry, public IP, okay, and there is a load balancer, and you can just say abc.com is resolving to this public IP, let us say 1.1.1.1, and 1.1.1.1 sending the traffic maybe to the US, to the EMEA, or to the APAC. Let me tell you, when you are doing such a thing for the DNS query, okay, this is not your actual traffic, maybe for the DNS I am saying. So let us say the DNS will see that, okay, which IP I need to give. It will give the IPs in the load balancing mode. So it can be round robin, it can be any load balancing what you are choosing. So it may happen that APAC user is going to the US, okay, EMEA user is going to the APAC, and US user is going to the EMEA. And again, our purpose is not fulfilled. That is how, where the F5 DNS will come into the picture, and it is named as GSLB solution, Global Server Load Balancing. So it does not do the simple server load balancing, but it does one more step beyond that, named as Global Server Load Balancing. So when we are adding the GSLB solution, it means our DNS is now very intelligent. Okay, this is an intelligent DNS resolution. So F5 DNS, one thing, the problem was like EMEA customers should be going to the EMEA, US should be going to the US, APAC should be going to the APAC. So this F5 DNS can able to recognize that, okay, depending upon lot of load balancing mechanism, which we will be going to talk in our classes, of course. So depending upon that, it will be able to recognize the location of the user. So if the user is from the APAC, it will not go to the EMEA. It will go to the APAC only. If his user is from the US, it cannot go to the EMEA. It will gonna go to the US only. DNS resolution is very intelligent this time. Secondly, the earlier approach was having one issue, that if US is down, that load balancer was not able to recognize. But this time, F5 DNS will monitor proactively if one region is down. Again, in US, there can be more than one data center, more than one DNS server. Okay, let us say if all data center is down, all the DNS servers are down, then only your request will be forwarded to the next nearest to you, okay, named as anycast routing. So depending upon that, your request will be gonna go to the email, let us say. So user will have some more latency, but not as such as in our previous legacy environment. So that is how we will be having more than one data center. And that is the reason we are depicting here 2 data centers. Okay, one is, let us say, APAC, second is the email. Now, After the GTM, there can be LTM. So we are placing here that GTM request will receive the DNS. This DNS request will go to the LTM. LTM will in turn send it to their application server. That flow we will see in email data center. Second, what I was talking about, that you can create your own LDNS here on these Unix machines. Okay, we will be gonna create those stuff here. So on this Linux machine, we will be gonna create our own zones. It will be the forward zone. It will be the reverse zone. What is the difference between them? Probably you would be more exploring when you are doing such things by your own. So in your forward zone and reverse zone, you would be answering the name to the IP and IP to the name, respectively. So we will be gonna create our A record, text record, SRV record, or blah blah blah. I would be gonna showing you all sort of those things in this LDNS servers. And again, we have a GTM which is having the APAC listener. Here is the email listener. So this whole thing will be gonna talk like this client will be gonna go to the EMEA or gonna go to the APAC depending upon the load balancing mechanism that we will be understanding in our practical classes. One thing you see, there is some sort of routing which we are performing among these data centers. Okay, so in this setup, you can see there is netting is also getting performed. This time the netting is inside. Here it is the netting of outside, which is interacting with the public cloud. And that is the reason like how we can perform our labs. So that is end to end how we will be gonna perform. One thing more, somebody is asking how we will gonna create them as a DNS server. There is a bind 9 utility. Okay, so during that bind, using this bind 9 utility, I will be gonna create my Linux machine as a DNS server. Okay, I hope you guys are aware about it. If not, even then it is also fine. I will be explaining about it. This whole course duration would be 20 to 24 hours or maybe more depending upon the batch. So syllabus you can just download. You can just use surfnetminion.net. Okay. Here, if you go into the courses and big IP DNS GTM, you can see our previous videos also. If you scroll down, here is the syllabus. Just click over here and you will get all the syllabus. Okay. So this is how your F5 GTM classes will work. Lab topology, I already showed you. These classes would be under the weekends. So weekends, when I'm saying it would be Saturday and Sunday, India based. Okay. So you just remember this is IST based timings and dates. So whatever your countries you are based on, let us say if you are from the USA, probably it can be, if it is the morning classes, it may be Friday and Saturday for you because your Friday will become our Saturday morning. Friday night will be Saturday morning. So that is how probably you need to convert that timing zones, or our team will convert it for you and will give you like what time in whatever time zone you are. Okay. And these classes will be based on the group classes or one-on-one classes, however you wanted to prefer, depending upon your understanding style, or maybe your questioning style, or maybe depending upon your timings, depending upon your learning. Now, this F5 GTM lab will be assigned to you guys. Very easy to run. Just right click, start this device. This device will gonna start. If I am clicking on this, it will be gonna boot up in a moment. See, this is booting up. Okay. This lab is 24/7 accessible, not some kind of time allocated to you. 24/7, you can just allocate as per your time. Also, whatever we teaching, okay, whatever we are teaching, let us say if you are not available for a class, you can see the videos. So videos, there is a videos portal. You can go to that video portal and access the video. Even if you are not comfortable with the live classes, you can just search for www.videos.netminion.in. When you go to this website, videos.netminion.in, okay, you can able to access our video portal, and you can purchase any of the video directly through this portal. So that is how end to end we will be gonna cover. If there is any more question, probably you can ask me. House is open for the questions. Okay, I can see one question, that what is DNS root server? So DNS root server, if I talk about, okay, DNS root server is nothing. Maybe you can say in your domain name system, there is a hierarchy, or there is a reverse, maybe you can say tree structure, which will be gonna adopted. It will be like root on the top, and then your branches. These branches can be your org, like .com, .net, bit like that. So this can be further delegated, like google.com. Okay, in the google.com, let us say hr.google.com. So these branches can just form in n number of steps. So this is your reverse tree structure, and your root server is on the top. This root server is mainly showing you all the essential part of your infrastructure of the internet. So we like it is a like on different forms, you can see that there are total 30 root servers available. Okay, but it's not true. There can be more than 13s also, but originally it was 13, and it is a very common misconception which everybody is speaks about. So if we talk about 13 root server, depending upon the anycast routing, your traffic can go to the any of the root server. But again, like I am telling you, there can be more than 13. There can be, let us say, more than 600 different root servers. So who operate these root servers? If we like, who is taking consideration of this? There is an organization named as ICANN. Okay. If I will go to the full form of this is Internet Corporation for Assigned Names and Numbers. So this is the organization which delegate the operation of your root servers. So as I told you, root servers mainly there is a misconception of 13, but there can be n number of root servers. Currently at present, I was going through an article which was showing that this time we have 600 or more root servers. So if one of the root server becomes unavailable, do not worry. Don't think that, okay, what will be going to happen? Another root server will come into the picture. Okay, if that will get down, another root server will come into the picture. One thing more, what I would be going to talk about, you can just follow us on the NetMinion blogs. So if you just see this NetMinion blogging website, here you can see, okay, can you see this DNS? If you click on this DNS part, you can able to see like, okay, how the DNS works. What is that, hierarchy of the DNS. Hey, even, before the DNS, there was some host file concept. We are describing about the host file concept over here. Then what is fully qualified domain name, named as FQDN, which has the protocol, domain name, root domain, that there can be, query string, there can be parameters, there can be value, there can be file type, lot of things can be there in a proper URI, but FQDN maybe ends up over here. So you can see the hierarchy of the DNS server, what I was explaining you earlier, that it would be a reverse tree structure. Okay, root will be on the top. So you can see what are the domains, what can be majorly used domains. It can be IN, it can be CA, depending upon your country also. And there are some like .com, .edu, org, or blah, blah. Okay. So you just go through this article also if you have some time. It will give you a fair understanding of the DNS. And please be in touch with us, maybe be in contact with us over this WhatsApp, through this chat, or maybe you can just go to the website. As I told you, if you go to the website again at minion.net, you can just like if you just go to the FI DNS, you can just join our Telegram group. So this is how you can enroll into the course and get the benefit for your career plans. Sure. Any other question? Oh, thank you. Okay, great. So thank you to all of you for joining this class. Okay, demo class, probably I will say. And we will meet you in the main theory session and with practical learning. Thank you all. Great day.